Hey, XSS Fox here with you again. Just going to run through a little bit about my portable DMR repeater. First up, I'm going to sort of break down the various components in here so you know what a duplexer is, what model radio these are and how you configure them. I'll also have a look at the voice repeater side of things, non-digital modes with the GR300, how you can configure that and set it up. Then we'll have a look at the DMR side of things. But yeah, this is my portable repeater, and the idea is to use it at events like Furdu and other sort of fun things where amateur radio people end up. So let me just give you a quick demo of it working. This is Victor Kilo 3 Fox Uniform Romeo testing 1 2 3.
Romeo, testing 1 2 3.
I'll also show you how to configure the various levels on the digital board that's sitting on top of this Pi. Alright, so let's run through the repeater system just from a analog repeater system point of view. So this is a GR300 stack, so that is sort of this outer case. And inside that we have a GR300. This is the repeater part of this system. So this is what basically connects these two radios together. We have a GM300 radio for the RX and also a GM300 radio for the TX. Down here we have the power supply. And right down the bottom is the duplexer, which you can't see here. I'm going to flip this around and sort of show you how it all works. Let's turn that on. You can see the lights. And these are just normal GM300 radios. They've just been configured to be a repeater. So these stacks you can get secondhand for pretty cheap. I think this entire stack cost me about 100 Australian dollars, and that included the two radios. Unfortunately, one of the radios was bad, so I had to replace that, which adds a little bit to the cost. But apart from that, everything else was working in this kit. So around the back, we have a mess of wires. One thing is I've removed the fan here just so we can get a good look inside the repeater system. Usually there's a fan in here. You can see the connector for it there. There's a thermostat there to control the fan speed. We've got the power supply down the bottom. Now, it's really important that you do have the fan on this under normal operation, because if you have a lot of conversations happening on your repeater system, these radios are going to get really toasty hot, so they need air going across them. Down the bottom, this is the duplexer. So I'll pull that out in a sec to have a look at it. But as we can see, we've got cables from the repeater module up the top here, and these are basically the control cables connecting the two radios together. So you can see in there is one of the control cables and one down the bottom, and that's basically just patching the audio between the two radios and also signaling it to start transmitting. Got power into the power supply. Most of the size of this is actually the DC power supply. This came with this radio, which is good. And then down the bottom we have the duplexer. Let's have a quick demo of this working in normal analog mode. Unfortunately, I don't have anyone to talk to, but we can ka-chunk it, and we can hear the courtesy tone and the ident. So the general things you need for a radio system is some sort of repeater controller, two radios, power supply, and a duplexer, and lastly an antenna. Let's break down some of these components. This is the trusty antenna system that I use. On the left we have an RFI antenna, and I've just mounted it with some bolts to this clamp, and that allows me just to clamp it up somewhere nice and secure. Added a little extra safety rope just in case this was to fail or the coax was to fail, that nothing can fall down if it's mounted up somewhere high. And this seems to give pretty good coverage, considering it's a sort of portable setup. So this is just an example of it being used how you typically would on a balcony. So this is one of the Motorola GM300 radios. These are pretty popular to come by in Hamfests, and also just on eBay from people selling old cars or decommissioning repeater systems. On the back we have your usual connectors. We have the power supply, the antenna. This is, I think they call it a mini UHF connector, but at least in Australia you can still pick these up at places like JCar. And then you have the accessory port, and so this is what the repeater controller would typically plug into. And basically there's pins out on here for TX audio, RX audio, and PTT, along with a bunch of other things like turning the radio on and that sort of stuff. So to program these radios, you use this mic auxiliary socket. And what you can do is grab one of these FTDI breakout boards, and I'll put a little circuit diagram up, but you'll see that there's a little diode across two of the pins between essentially receive and TX, and then we have two wires coming out on there, and that just plugs straight in there. Use DOSBox to program these, and I might run through a quick tutorial on the PC on how to program them. So I haven't been able to get the radio software working on Windows 10, but if you get DOSBox and configure the serial port, you should be able to read off the radio. I'm just going to use a file to run through how to configure this radio to start with. So in this menu here, the Get Save menu is where you'd typically read. Then if we back out, there is the change in view code plug data. So on F4, you get to see that. So radio wide configuration, F2, is where you configure basically anything that's not channel related. So under accessory information, if we tab across to that, this is where you actually, this is where you set what type of repeater it is. So if you're using the ZR310, I believe the setting you want under accessory external is community RMT, I think, but check the ZR310 manual to be sure. So then under F5, under mode configuration, this is where we set the frequencies, and you only really need one channel on your radio, but I like to configure it with both the receive and TX as different channels, just in case you want to swap which way around the radios work. So under a normal repeater setup, you'll have the RX and the TX frequency for one channel being exactly the same, because that radio is only going to do one thing. It's only either going to be an RX radio or a TX radio. Can't do both at once. So just set them both the same. You can actually also blank out the TX frequency, so it's only receive on the receive side. That's an option as well. It doesn't really matter too much. For the tones, you want to turn those off. Let me see, up, down. So CSQ is the Motorola way of saying it's just a squelch level. So you don't need to have any tones set. That's something that would be done by the repeater controller. Otherwise, it's going to look for a tone that's not there, especially when you're using it as a digital repeater. RX signaling system, you can just set to none. Same with the TX squelch type as well. TX inhibit on busy, that's personal preference. It's up to you to work out. And also the local distance, or DX, It's usually better, I think, to just leave it on the DX. It just changes the sensitivity of the squelch. So once you go through and configure all of this, you just go back out, go to get and save again, and then F8 is the program radio. One thing you'll want to consider if you're using a fairly modern machine and running it under DOSBox, you actually need to slow down the CPU cycles to about 190. I think it depends a little bit on your machine and serial port and that sort of thing, but around 190 is when you'll start to get the serial port to work. Just keep that in mind. It's very fiddly to get this to work on a modern machine. It can take a little bit of work to work it out. So with both the ZR310 analog repeater and what I'll show you in the future, which is the DMR repeater, you do need to set some jumpers on the radios themselves for them to operate correctly. I will put up an excerpt of the manual for the ZR310, which goes through what jumpers have to be set, and that should help get that right. And if I remember, I'll try and put the ones for the DMI repeater as well. So you'll see here are all the various jumpers, and these will depend on if it's the TX or RX radio and what they should be set to. There's also some software configuration that needs to be done to make these compatible with the ZR310, but it's pretty trivial once you've got the radio programming software working. So the duplexer is held in from the bottom. So this is the duplexer. Alright, duplexers. So this is the flat pack duplexer. We've got 3 ports here. We've got the middle one, low and high. So the middle one's the antenna. That's where you'd typically stick your antenna. And then you'll have a low side and a high side. And these could be flipped depending on the manufacturer. So make sure you find out which one's which. This one was purchased off AliExpress, and when you purchase them, you select what frequency you want the duplexer to be made for. So you can tune these yourself. Things like the Nano VNA probably aren't quite good enough to use to tune these. But if you've got a high quality VNA or a good tracking spectrum analyzer, you can possibly tune these yourselves. So there's not much to these. What they're filled with is air, which makes them magic. So what do duplexers do? So why we have a duplexer is because we need both a TX and an RX radio. So say we have our TX radio and our RX radio. What the duplexer is doing is basically selecting one particular frequency. For example, in our case, 449 megahertz and 441 megahertz. And this lets us use one antenna, 2 different frequencies, and 2 different radios. Internally, this is basically just a set of filters, and it's preventing the TX from this radio ending up in the RX of this radio. Instead, the TX just goes out the antenna, and the antenna goes straight into the RX. That way we can have 2 things essentially connected to the same radio. might be thinking, why don't we just have 2 antennas? Well, antennas don't act as good filters. So say we were to just do this, and we've got 2 antennas. What's going to happen is when this radio TXs, this radio is going to receive it, because these don't make good filters. And what that means is this is going to overpower your receive signal. So you might have a very weak signal coming in from your 5-watt handheld somewhere on the beach. It's going to come into this receive antenna. The repeater system is going to TX, and then it's going to overwhelm the RX antenna. So that's why we use a duplexer to essentially filter out the transmit frequency so that the receive side can hear the weak signals that we're getting in. Alright, I've broken out the spectrum analyzer so we can get a little bit of a look as to what's going on with a duplexer and how it's working. So this is just one particular kind of duplexer. There's a whole bunch. So these ones are called flat pack duplexers or notchplexers, are the common names for it. Now, I've set up the spectrum analyzer in tracking mode, so it's basically just sweeping the signal across and looking at the loss across that signal. So I've got my marker set here to roughly where our high side of the signal is, and we're currently connected to the low side of the duplexer. So we got the antenna is where the tracking signal is coming in, and then we're sampling off the low side. So as we can see in here, there's this big dip down here, like 64 dBm dip where our normal high side is. So basically what that's saying to us is this low side can't see anything that would be transmitted on the high side, or at least, minus 65 dB of that. So that's really, really good. Now, what I'm going to do is I'm just going to freeze this. Oops. Freeze. There we go. So freeze that. We're going to select number 2. And so number 2 is showing up there now. And now I'm going to move this over to the high side, and we'll see what we get. So if I move that across, we can see on this side, we've got another notch. So if we have a look at where our marker is, so if we put our marker back where we were before, the 449, which is our high side, we can see that there's very little loss, 2.5 dBm. I haven't calibrated this, so that is possibly part of the testing setup. But it gives you an idea that there's very little loss when we're at the right frequency for the side that we're on. And then if we go down to our low side, so we're at 441.0, close enough, we can see that there's also about 63-ish dBm loss on that. So basically what's happening is we're combining these 2 filters to let us have one antenna output, and that's sort of how it's working. So you can program the GR300 over the air, and I'll put a link in the description for a manual for it, because there's lots of things to configure, and I'm not going to go through them all, but I just want to demonstrate entering and exiting the program mode, so you sort of have an idea of how to get in and if it's working or not. So the default access code is 12310#. It's possible that yours might be different, considering that it might be from a secondhand pre-used condition, but the default one is this, and you can set it in the configuration to whatever you like. So to enter it, all you have to do is key up your radio like normal, type it in using DTMF tones, you'll hear 3 beeps, and that means you're in the setup menu, and you'll notice that it's still TXing. So that's to show you that you've successfully entered it and you're still in setup mode. Now I can still hear you, so let's exit, and to do that it's 99 followed by the hash key. So you'll hear that tone, and that's to prompt you that everything's been saved and you've left programming mode. To give a bit of a demo of how to configure this using the TTMF tones, I'm going to log in, then I'm going to ask the system for how many users are enabled currently, which is this 360 hash. Users in this case is CTCSS tones, how many enabled CTCSS tones. And then I'm going to exit the menu using 99 hash. So 3 dots means we're connected. It's still transmitting. We can send our next command. 360 hash. There we go. So we've got now our number of users. Now we can exit. So one thing to note is if you're programming up these radios from scratch, what you want to do is make sure the timeout timer is either very high or disabled. Otherwise, if you're going through the menu system, it'll be dropping out throughout the process. So we've had a look at how the analog side of things work. So let's step it up a little bit and have a look at how we get DMR working. So what I have here is a STM32 DVM board, which is made by Repeater Builder. Repeater Builder has a whole bunch of information on all things repeaters, which is really, really handy. Lots of information about Motorola repeaters, which is great. And that's sitting on top of a Raspberry Pi. This is just half in a 3D printed case here. Now, from Repeater Builder, you can get this cable pre-made, or you can make it up yourself. It's a DB9 to the Motorola little jumper pins. These aren't hard to make up, but it doesn't cost much more to get one already made. So that goes into this DB9 port of the Repeater Builder shield that goes on the Pi, and that's what connects to these radios. So as I was saying before, there are jumpers that you need to change on the radios, and once you do that, you should be all good. One thing to note is there's several variations of the GM300, and I'll tell you and show you what that means later, but only some of them out of the box will work with this shield. Others will require modifications. I got really lucky and I have one of the ones that doesn't require modification. Victor Kilo 3, Fox Uniform Romeo.
Victor Kilo 3, Fox Uniform Romeo.
Okay, so I'm going to quickly run through how to configure the levels on the STM32 DVM board. It's pretty simple. It's really easy to do on this particular board. Some of the others are a little bit harder. And the reason why it's so simple on here is if we look all the way over here, and hopefully that's in focus, there's a clip light. So it's currently off at the moment, but that lets us set the RX level pretty easily. So what we want to do is we've got 2 pots here to control. We have the gain and we have the RX in, attenuation in. So this one here we want to turn all the way down, so there's essentially no gain on the signal, but then we want to basically back off the attenuation until the clip light comes on and then go back again. So let me demonstrate what's going on. So we want essentially what we're aiming for is as little attenuation as possible and as little gain as required. So let's that's currently all the way off. So if we turn that on, so we can see that's clipping now. So we want to back that off just a little bit into that light. You'll see it flicker just until it's not flickering at all. What I've got set up now is I've got a SSH session into the Pi-Star box. I've got Cubic SDR. It doesn't matter what SDR software you're using, you just need some sort of SDR. And I've got a RTL SDR over here. It doesn't even have an antenna attached, it's just sitting right next to the dummy load. It might be a bit better if you have an antenna attached. It might be a little bit easier to do this, but we'll see how we go. And MMDVM ready to go. We just need to run this command, which is just it kills the MMDVM host on the Pi-Star box and starts up MMDVM cal, which is a calibration utility. So I'll run that now. And it takes a little second, but it will connect to the DVM box. What I can do is I can type in capital D for DMR, and it will go into DMR deviation mode. And this lets us quickly test the deviation setting, which is really sort of the TX level that we're feeding into the radio. If I press space, you can see it starts transmitting. And so what we're after is essentially 5 peaks on the left and 5 peaks on the right and nothing in the center. Now, if your radio is only showing maybe 3 or 2, maybe even 4 peaks, it probably means that you need to modify that radio to work with the STM32 DVM board. And that's because it has some sort of filtering in it. So some of the GM300s require removing filters or feeding the signal into a different spot. Luckily, this one doesn't require that. So if you hit space again, it'll stop transmitting. There is this TX pot here, and that lets you change the, the attenuation on the TX level. But there's also on the software side of things, if you press lowercase t, it will decrease the signal, and uppercase T will increase the TX level. So what you're after, if we have a look in here, is we want that center line to basically be gone. So if I lower the level a bunch, you can see that center line is quite loud. And that's no good. So to get a proper level for DMR to work, what we want to do is bring that up until that center disappears, and you can see it just starting to disappear, and it's a pretty small range which it will disappear in, and the transmitter does turn off after a time, so if the signal goes away completely, just keep that in mind. So somewhere around 50% is what I've got this set up to do, but there's also the pots on the PCB that will let you adjust it as well. Once you work out what your TX level is meant to be, in this case it's 50%, you want to go into Pi-Star's expert editor and then under the MMDVM host. Once you're in there, if you scroll down, you'll see the modem TX level. That's what you want to set the 50% into. The other thing to take note is, at least for my setup, I need TX invert to be 1 and RX invert to be 0. If you don't have a GM300, it could be completely different settings, but at least for me, that's the settings that I require for my radio. You'll have to do a bit of research or experimentation to work out which way around those should be set. Alright, I just wanted to quickly show you what happens if you have one of the radios that isn't supported, or if you have the jumpers set wrong. I can hit transmit, And you can see in this case there's only 2 peaks in this particular radio. So if I increase or lower the transmit, you'll see that doesn't really change enough to get the required 5 peaks out of the radio. So if you come across a radio that is similar to this, in that you can set the power as high as you like using both the pot and the software level control, and you can't get those peaks when you run MMDVM cal, it means that you've got one of the GM300 radios that isn't supported out of the box. There's instructions online on how to do modifications to make it work, but yeah, it's a little bit of extra work, and luckily I don't need to do that. Alright, so that completes our little tour of how this repeater is set up, how you can use it for analog and also for digital modes like DMR. Hopefully this has been useful to you. I know you've probably got loads of questions and lots of things that I've missed out, but this video is already way too long, and I'm already concerned about how long it's going to take me to edit. But if you have any questions in the comments, I'll try and get back to you. There's lots of resources available on the Repeater Builder website. It's a good place to start for anything to do with repeaters or old radios. And yeah, have a lovely day, and hopefully I'll see you in a future video.